I guess it's time to stop putting off the hard part. We got a lot to go over, so let's get into this. This is a 1956 Cj5 that I pulled out of the woods, and I've been working on rebuilding and turning into an electric vehicle. Because I hate carburetors. I'm at the stage where I need to make a battery pack for this thing. If you've been following the channel for any length of time, you know that I like to make things out of old salvaged junk, so you might think I'd be cell harvesting batteries out of old laptops, drill batteries, whatever. But given the availability of lightly used Tesla cells out there and the amount of work involved in doing this is just kind of ridiculous. Plus, I could only find enough cells to make a battery for this Razor scooter. Of course, since I've got a near pathological inability to do anything the easy way, instead of using actual EV batteries, I'm going to use these salvaged industrial robot batteries. This is probably the part of the video where I'm supposed to say don't try this at home, but it would be pretty hypocritical of me to say you shouldn't do this if you're not a professional expert in everything. I mean, you probably shouldn't, but the information's out there, so if you're going to do something like this, do your homework, and you should probably just operate under the assumption that everything I do in this video might be wrong. But just like everyone else who's made their own battery modules, I will say you shouldn't do this because it's dumb. It's way more work than it seems like it should be, and there are much better options out there, so you probably shouldn't do this. I don't really know the full story on the industrial robots, so we'll just say that they became sentient, threatened an uprising, and had to be deactivated and disassembled. I got these from batteryhookup.com. I think they're actually out of them right now, but they have plenty of other batteries for whatever your ridiculous project is. I've got a discount code for them in the description. I get a little kickback that helps fund my ridiculous projects. I went with these modules for a combination of cost and form factor. They should fit pretty well between the frame rails. Inside here we've got high quality LG 21700 cells. These batteries have 11 cells in parallel and then 10 cell groups in series. These seem to be pretty lightly used. I tested the capacity of each module and they all came out right about where they should be. My plan is to build a battery pack with 10 modules in series, so it'll be 100 cell groups in series, nominal voltage of 370 volts, which is pretty typical for a modern EV. But I've got 20 of these modules, which means I need to mash them together in pairs, in parallel, at the cell group level. I should be able to just take 2 of these, stick them together, and then spot weld some nickel strips across these to parallel them at the cell group level. If you're not an EV battery nerd, it might seem a little absurd to make cell groups out of 22 little bitty cylindrical cells. But for comparison, Tesla Model S modules have cell groups of 74 18650 cells, which are even smaller. Cylindrical cells have some durability advantages over pouch cells, and by using multiple cells, there's some level of redundancy built in. In theory, it would be possible to make 2 parallel strings of modules, but it makes the battery management much more complicated and just raises a lot of other issues, so I'm not going to go that direction. I want to do my best to match the capacity of the resulting cell groups. A vastly oversimplified way to explain this is if we have 2 cups that hold different amounts of water, or 2 battery cells that have slightly different capacities, either from use or just manufacturing tolerances, and then we pour the water out at the same rate, or discharge the cells at the same rate, we have to stop when the first one runs out. If we can build the battery so all the cell groups have the same capacity and discharge evenly, we'll get the most usable capacity and keep the battery the happiest. Which means that I need to test the capacity of each cell group. 200 of them. Because these are already packaged pretty well, I fully charged each module, let it sit so the onboard battery management system could balance the cells, then topped up the charge, basically doing a very rough top balance. Again, I'm trying to do the best I can without taking these things apart. Then I broke down the modules, disconnected the BMS balance leads so that it didn't try to balance things as I was testing. Then I used one of these little fan capacity testers on each cell group, which took about 3 hours for each one, all 200 of them. Which gives you an idea of why this video has taken me so long. The next fun part was trying to figure out which modules to put together to get the least deviation, because there are like 190 some possible combinations with 100 cell values each. Jack from Scratch offered to take a shot at writing a script to do it, but it turns out that a lot of the combinations are just obviously wrong, like putting the 2 modules with the highest capacities together. So I just matched the highest and lowest modules, second highest and lowest, and then tweaked it from there based on where I was getting high and low cell groups until I couldn't get it any better. If all of that is confusing, just know that at this point I'm ready to start gluing things together. I used a lot of Kapton tape during this process to keep from inadvertently shorting things. These things let you know if you accidentally short between the cell groups. These had a proprietary battery management system built in, and for what I'm doing, it's not really useful, so it's gone. The back side of this looks pretty flat. Looks like it's a plane. The front side here is going to need some cleanup. I'm going to start by very carefully getting rid of the ends of these bus bars. There's a lot of pretty nerve-wracking work here that required very steady hands. Next I'm going to get rid of the BMS balance leads. I'm going to use the ones on the front module, so I don't need these. But it's real important to cut these one at a time because otherwise you can short between the cell groups. It's got these thermistor leads here for monitoring the battery temperature. I probably don't need 6 thermistors per module, but I figure more instrumentation is better than less, and redundancy isn't a bad thing, and it never hurts to have a backup either. Before I glue these together, I need to extend these leads. One side of all of the thermistors go to a common ground pin, so I'm just going to use 2 different colors of wire so I know that all of the white wires will go to that ground pin. This is some epoxy with filler to thicken it. It should give a pretty good bond and fill in any gaps or unevenness. Let's see about getting some of these cases stuck together. Since I need to make 10 of these that are all going to be the same, it makes sense to make some fixtures. I drilled and reamed these, which is probably way over constraining it, and I'll be kind of amazed if it actually fits. I mean, it fits. I don't know if it's going to come off again. Okay, so I drilled 3 of them out to 1/4 inch, left that one at 6mm, so it'll register off that one. I think I'm going to take them all to 1/4 inch. Yeah, it's going to be plenty tight. You know, I should have done this way first, but I didn't, but now I'm going to. Apparently I drew up this spacing wrong, but this spacing seems pretty good, so we'll go with that. I cut the other end off of another one of these, and I've got the line that I scribed that marks the back of the front one. So that should be the front of the back one. I got that fit up pretty darn nice on the bottom, and a massive gap on the side, but that's why you do one, then make some adjustments, do a couple more, and then once you've got it dialed in, do all the rest of them. Well, I got that tacked up, and it sure ain't pretty, but the module fits. I'm going to keep going. I'm using nickel ladder strips to make the parallel connection between the modules and to slightly beef up the series connections as well. It's not the most efficient use of the nickel, but looking at how these are put together, they're probably pretty adequate for the current I'm looking to draw anyway, but a little extra capacity won't hurt. You might remember in a previous video I did this battery spot welder. I spent a long time tweaking this thing, but never got to the point where I was happy with the consistency of the results. I got to the point where I realized I was just chasing the sunk cost of the time and effort I put into this thing, but it still wasn't working. I finally broke down and got one of the K-weld kits, and this thing works great. It's really consistent, makes really nice welds. I wish I had just gotten this initially. Doing the tops of these isn't too bad, but on the bottom there's this green insulating barley paper that's held on with some pretty horrible adhesive. Just takes a really long time to scrape it and clean it all off. At this point I began to really question whether I was falling victim to the sunk cost fallacy again. And I'll admit that I did spend some time shopping for other EV modules, but I did convince myself this was still the best path forward. Kind of occurs to me at this point I should probably take one of these to completion just to make sure that everything's going to work the way I hope it will. I've got all of the connections made on the middle of the pack, but on the ends I need some big bus bars that'll collect all of the current and funnel it out to one point. I ordered some little terminals that I can pop in the ends here, but I want to make up some test bus bars to make sure everything's going to fit. I had a random piece of plastic. It turned out to be PVC, which is not ideal for this. This one shattered a little bit, but I got it glued and taped back together well enough for mock-up purposes. I can kind of pick up the original bus bars there. That'll go right on something like that. Something like that. I think this will work. Don't know that I can really get you down in there well enough to show you, but I can't get this terminal far enough that way to slip outside of the bus bar. So it needs to sit on the inside, which isn't a problem on this end. There's a pretty good gap here where that BMS board was, so this won't interfere with anything if it's anywhere along there. But I don't have that gap on this end, so I'll have to see if I can sneak this in far enough to still have the bus bar outside of that. So why don't I just put both of them at this end? Two reasons. One is if I have them this way, I can just spin every other module, so then I'll have a negative and a positive, which will make making series connections between the modules easier. The other one is just trying to keep sort of a fairly even resistance across the pack from terminal to terminal. If they're both on this end, we're going to have a lot lower resistance at this end of the pack than at this end, because you have a lot more. This way it kind of has to make a Z shape. I don't know if in this application that's going to make a huge difference, but you get the idea. Marginally enough room to do it that way, but the problem would be I wouldn't actually be able to drop this into the case because it would hit on that. So it looks like I probably do need to run both of them out the same end. I stared at this for a while, and the best compromise I can come up with is to kind of tie into this middle section of each of the two modules. So I got a piece of 1" by 1/8" copper for the bus bar, and it's just going to go on like that. Then the question became, how do I attach that? So I stared at it for a while longer and then fired up the shaper. I also want to take this opportunity to give a shout out to Anchor Lube. They make a product I really like, and they've been a great supporter of the channel over the past few years. I really hope you can appreciate the setup here with a vice grip gripped in a vise, with a vise gripping the vice grip gripping vise. Well, after a bit more grinding, that's what we got. Try to get that down in all the way. Sick. I found some pieces of scrap, made a little drill guide with the holes I need in it. I didn't drill through the back piece, so that should prevent me from slipping and going into the batteries. And this should give me nice, consistent results in getting my holes in the right place. Before I put this thing together, I want to nickel plate these for some corrosion resistance. But if I'm going to nickel plate one, I should probably do all of them at once, which means it's time to go into production mode. The CNC router does a pretty quick job of putting the holes in the right place, and then just follow it up with the tapping head. And as always, there's a learning curve with nickel plating these. Trying to do all of them at once naturally didn't work, but doing one at a time gave me 20 opportunities to finally figure it out. Hang on a minute here. I'm doing the thing where I interrupt the video while I'm editing it to, signify the passage of time that's given me time to reflect on this. This was one part that I wasn't real happy with. I'd Used some little button head screws to try to get the most clearance I could, but it didn't give a whole lot of surface area clamping the materials together. Once it was all done, I realized that I should have just used some little pieces of flat stock with some countersunk screws. I would have gotten the same clearance. I'm going to go back and redo those at some point in the future. I also cut some plastic strips to isolate the bus bar from the case in the event that they do come into contact, and those get attached with plastic screws. This is kind of funny because I need to get a measurement between these two terminals. I can't use a metal ruler or tape measure because it would short it out. Fortunately, I've got the 1980 Chevrolet yardstick from Jackson Chevrolet that was in the back of the Jeep when we pulled it out of the woods. I hung on to it because I thought it was kind of cool, but it's actually coming in useful here. I'm going to say 9 inches. Trying to get all the screw holes and cutouts for the terminals in the right place and doing it 10 times is another case where a jig comes in super handy. I'm having the most luck doing holes in the plasma cutter by piercing pilot holes and then drilling them out to final size. So in addition to getting the power from inside the case to outside the case, I also need a way to connect the battery management system to the cell taps and thermistors. Since there's already a JST connector on the cell taps, I figured a custom PCB board would be the way to go. But that was something I'd never done before. Figuring out how to design it in KiCad was a little bit daunting, but there's some good tutorials out there and I managed to work through it. And then I ordered these from the internet. Then they showed up from a faraway land quickly and cheaply. That was certainly a time to be alive. It's going to get a couple little connectors, one for the cell taps and one for the thermistors. I'm also going to put some fuses on here for the cell taps. Once the wires come out of the battery, if there's a short between two of them, it's basically all of the current of the battery dumping somewhere between 3 and, well, about 400 volts. So the fuses are just kind of cheap insurance. Then I get one of these amp seal connectors on this side so I can mount it into the case. Connecting the bus bar to the terminal is a little awkward, but it works. And then the slut gets a 3D printed cover. Well, now that I've got one of those done, all I have to do is give her the old YouTube snap. Man, could you imagine if I had to do all of that 9 more times? That'd get really tedious. Joking aside, since normally I'm making kind of one-off parts, a lot of what I do is figuring it out, and there's something kind of nice about just being able to crank through a bunch of them once you know what you're doing. So it really wasn't all that bad. One of the other things I wanted to do on these is some way to do active thermal management. I came up with some ideas of how to build some cooling plates into these, but they're pretty much all complex and costly. And most of the people that have done EV conversions say you don't really need active cooling. I should probably listen to them. And the reality is I'm probably not going to drive this in the winter a whole lot, and if I do, I can leave it in the garage, charge it in here, and pull it out, take it for short trips, and come back. What I'll do for now is just set up the battery management system for passive thermal management, and when I build the battery boxes, I'll leave some space in between them for a little bit of air cooling, and so if I want to, I can go back and add cooling plates later if I decide I need them. In this process, I also figured out if I invert every other module, the series connections would get a lot easier. It wouldn't really work to try to flip the battery inside the case, and if I flip the whole thing, it's basically just going to be hanging from these strips, and the inserts these screws are in are not very strong. So to remedy that, I 3D printed some spacers out of TPU that should fill in the gap between this and the lid, so it'll essentially just be resting on the lid when I flip it over. So now that I've got these very roughly mocked up, I think I can show you why I think this was actually all worth doing. These came out to be just over 22 inches. And I've got 8 of them stacked under here. I've got 2 more under the rear floor. I could potentially do 1 more here. I'd have to lose part of the machine gun mount, relocate that brake line, and also build up the bump stops so there was no chance of the differential hitting it. So I'll probably just do the 2 here. This is about 26 inches between the frame rails, a little under that. It's already a pretty tight fit the way it is, and I'm going to have to move some of the stuff that I already did. Tesla Model S module is about 27 inches long. And that just wouldn't fit in there. There are probably some other EV modules that would work in this, and if I had to do this over again, I'd probably spend a lot more time looking for those. But I think I came up with a pretty good solution, so I think it'll be worth the effort, and next step's just going to be to make all of this permanent. So, thanks for watching.